Hello children, welcome back to my channel. Now I am dealing with the 10th class coordinate geometry, and in this coordinate geometry, in the previous class I have done about various formulae for finding out distance between 2 points. The formulae we're dealing with the points lying on x-axis, or the points lying on y-axis, or the point lying parallel to x-axis, or the points lying parallel to y-axis. And also we have talked about when 2 points are there, one on x-axis and one on y-axis, how to find out the distance. Now this topic is dealing with distance between any 2 points on x and y plane. That means they don't have either x coordinate or y coordinate as the same. That kind of points, about that we are going to consider. So let us see this as the x and y axes. So let me take a point A here and a point B here. Coordinates of A is x1, y1, and coordinates of B is x2, y2. Now you want to find out the distance between A and B. How to find the distance between A and B? Let us go for the derivation. Now, coordinates of A is equal to x1 comma y1, and coordinates of B is equal to x2 comma y2. Now we want to find out the distance between A and B. You have got a small construction here, children. What is the construction? Let me write a little bit away. I need space here. So what is the construction that you have to do? You have to draw a line AP perpendicular to x-axis and another line BQ, which is also perpendicular to x-axis, and AR perpendicular to BQ. These are the three constructions that are required to derive an expression for it. So what is the first one? Draw AP perpendicular to x-axis, and second one, draw BQ perpendicular to x-axis, and third one, draw AR perpendicular to BQ. Now we can say that in this case, children, when we have drawn these perpendiculars, triangle ABR, if you take, this is perpendicular. So in triangle ABR, angle R is 90 degrees. So since angle R is 90 degrees, we can say that AB square is equal to AR square plus BR square, basing on Pythagorean theorem. You can say AR square plus BR square. But what is AR, children? AR is the line parallel to PQ. So a line parallel to PQ, that is on x-axis, has got the value as modulus x2 minus x1. So what is AR square? AR square can be taken as x2 minus x1 whole square. Here we need not take modulus, because modulus in the sense always we need to take positive. So even if you have a negative value here, when you are squaring, you are going to get positive. So no problem, you can write it as, you can write this in this way. Similarly, let me take B. Now BR. What is BR? BR is a line which is parallel to x-axis, because these two are parallel lines. Perpendicular to the same line means they are parallel. BR, BQ is parallel to y-axis, sorry. BQ is parallel to y-axis. So BR is also parallel to y-axis. And in the previous class we have learned, if a line is parallel to y-axis, then the distance can be measured by using the formula y2 modulus y2 minus y1. So what is BR square? Y2 minus y1 whole square is BR square. Now the problem is AB square. I'll do it here. AB square is equal to AR square plus BR square. That means what is AB? Root of AR square plus BR square, means AB is equal to root of, what is AR square? AR square is x2 minus x1 whole square. x2 minus x1 whole square plus BR square is y2 minus y1 whole square. So this is the derivation for distance formula, children. We call this as the distance formula for any 2 points for which are lying on the x and y plane. Here x coordinate has got its own values, x coordinate, and A has got its own coordinate values, B has got its own coordinate values. In the earlier case where we have studied, we have got one equality, if you remember, either y coordinates are equal or x coordinates are equal. Because of that, you have got a different formula to solve the distance. But in this case, both x coordinates and y coordinates are different from each other. Since they are different from each other, how will you find out that distances? That will be doing a derivation, with the help of which you can understand the formula. This is only a derivation. In case if they ask you to derive the distance formula, this you need to do, children. So in this distance formula, you have got the, ultimately you have got the formula as a distance between any 2 points is root of x2 minus x1 whole square plus y2 minus y1 whole square. This is the formula which we are going to use for the most of the further problems in this chapter, children. Please note it down. Now example 3, children. Example 3 is, find the distance between A4, 3 and B8, 6. So coordinates of A is equal to 4, 3. So you consider it as x1 and y1. Then coordinates of B is equal to 8, 6, x2, y2. They are. Now AB. How will you find out AB? The formula, let us write, root of x2 minus x1 whole square plus y2 minus y1 whole square. So that is equal to root of x2, 8, minus x1, 4 whole square. See, children, when you write this, it is very easy for you to take the values. Otherwise, again and again thinking, sometimes you may go wrong. So always I prefer you to do it like this. Plus y2, 6, minus y1, 3 whole square. So that is equal to root of, how much? 8 minus 4? 4 whole square plus 6 minus 3? 3 whole square. So AB is equal to AB is equal to root of 4 square is 16 plus 3 square is 9. That is root of 25, that is 5. Therefore, AB is equal to 5 units. This is the answer. This is the answer for the third example, children. Please note it down. Now do this sums, children. In this, do this sums. Find the distance between following pair of points. So, first problem is 7, 8 and minus 2, 3. That means x1, y1 is equal to 7, 8. x2, y2 is equal to minus 2, 3. So now we want the distance. What is the distance formula? Root of x2 minus x1 whole square plus y2 minus y1 whole square. That is equal to root of x2 minus 2 minus x1 7 whole square plus y2 3 minus y1 8 whole square. Root of minus 9 whole square plus minus 5 whole square. That is equal to root of 81 plus 25. So, how much is that? Root of, this is 5 plus 1, 6, and 106 you are getting. So, what is 106 prime factorization? So, when you take 106, 2 5s are 2 3s are 53 is also a prime number only. So we have to take it as 108 only. This itself is the answer for this problem, children. Now let me go for the second one. X1, first let me write the problem. The problem here is minus 8, 6 and 2, 0. Therefore, x1, y1 is equal to minus 8, 6. x2, y2 is equal to 2, 0. So, distance formula is root of x2 minus x1 whole square plus y2 minus y1 whole square. So that is equal to root of, what is x2? 2 minus x1 minus 8 whole square. So bracket will change because of the bracket here, plus y2 0 minus y1 6 whole square. That is root of 2 plus 8 whole square plus minus 6 whole square. Root of 10 square plus 6 square. That is 6 square means I can write it as 36. 10 square plus 36. So 10 square plus 36, 10 square is how much, children? 100. 100 plus 36, root of 136. So 136, 2 6 are, 2 8 are, 2 3 are, 2 4 are, 2 1 are, 2 7 are. That means root of 2 into 2 into 2 into 17. That means out of 2 2's 1 2 I can take it out. Root of 34. 2 root 34 is the answer for this bit, children. So please go through it. Now example 4. Example 4 is show that the points A 4 comma 2, B 7 comma 5, C 9 comma 7 are 3 points lying on the same line. That means what, children? If you take one straight line in this way, A, B and C are lying on the same line, you have to say. So, what are they have given coordinates? Coordinates of A is equal to 4 comma 2 and coordinates of B is equal to 7 comma 5. Coordinates of C is equal to 9 comma 7. Now if A, B, C lie on the same line, actually what do you mean by this, children? They are collinear points. Collinear points. The points, some cases, sometimes they'll ask that they are collinear points. You prove that they are collinear points. So collinear means they are lying on the same line. Then AC is equal to AB plus BC. Yes or no? Total distance is this plus this. In that case only we can say that they are lying on the same plane. So let us go for the distance formula for finding out AC. So AC is equal to distance of AC x2 minus x1 whole square plus y2 minus y1 whole square. So earlier I have not kept x1, y1, x2, y2 because I need to take them as pairs. So if for every pair you have to take x1 and x2. So A coordinates are what? 4 comma 2. 4 comma 2. So now I will take them as x1, y1. And C coordinates are C coordinates 9 comma 7. So I will take it as x2 comma y2. That is why I have not taken their children. So what am I getting? Root of x2 9 minus x1 4 whole square plus y2 7 minus y1 2 whole square. So let me continue, children. I will continue from here. I need a lot of space to do this sum. So AC is equal to root of 9 minus 4 is 5 whole square plus 7 minus 2. This is also 5 whole square. That is root of 25 plus 25. That is root of 50. So root 50 means, how will you do, children? 50 means 2 25s are 5 5s are. So you will be writing it as root of 2 into 5 into 5. So instead of 2 5s, 1 5 comes out. 5 root 2 is AC value. Now let us go for the next one. AC we have found out. Now AB and BC you have to go. You have to do. So what is AB? AB. What is AB, children? AB is again root of x2 minus x1 whole square plus y2 minus y1 whole square. So A and B, coordinates of A you have got 4 comma 2, coordinates of B you have got 7 comma 5. So this is x1, y1, x2, y2. So root of x2 7 minus x1 4 whole square plus y2 5 minus y1 2 whole square. So how much are you getting? Root of 7 minus 4 3 square plus 5 minus 2 3 square. That is root of 9 plus 9. Root of 18. So 18 means 2 nines are 3, 3s are root of 2 into 3 into 3. So 2 3s, 1 3 comes out 3 root 2. You are getting the distance of AB. Now we need to find out BC. So how will you find BC? Root of x2 minus x1 whole square plus y2 minus y1 whole square. So let us take B and C. B coordinates are 7, 5. C coordinates are 9, 7. So x1, y1, x2, y2. So root of x2 9 minus x1 7 whole square plus y2 7 minus y1 5 whole square. So root of 7 minus 9 minus 7 is 2 whole square plus 7 minus 5 is 2 whole square. That is root of 4 plus 4. 4 plus 4. Let me continue here. So BC is equal to root of 8. 8 means root of 2 into 2 into 2. So instead of 2 2's, 1 2 comes out 2 root 2. So let us find out what is AB plus BC. AB plus BC is 3 root 2 plus 2 root 2. So since these two root 2's are same, 5 root 2. So what is 5 root 2? 5 root 2 you have got AC value. So this is equal to AC. Therefore, AC is equal to AB plus BC. Hence, proved. We have proved it because we have written that if these are on same line, AC should be equal to AB plus AC. We have taken that the AB plus BC is equal to AC. So we will be saying that the points are collinear. Even you can write that here, children, instead of directly writing hence proved, you can write therefore the given points are collinear. Then you can write hence proved. Write out this, children. This is example 4. Now example 5, children. Do the points 3, 2, minus 2, minus 3, 2, 3 form a triangle. Let us have a small discussion about this problem, children. When 3 points are given, you have got one property. If you join all the 3 points, you will be getting a straight line. Otherwise, with the 3 points, you will be getting a triangle. There is no other go. There is no other way in which you can join 3 points. When you join 3 points, either you will be getting a straight line or you will be getting a triangle. Now the problem is, do they form a triangle? That means if you could prove that the points are not collinear, that means the 3 points are not lying in a straight line, then you can prove that they form the triangle. So we have to do it is just like that of the previous problem. Very important sums, children, this type of things. So we need to see whether they are collinear or not. Then you can directly say that if they are collinear, they can't form triangle. If this case arises, this will not arise. If this case arises, this will not arise. So if you are getting a straight line, triangle will not be formed. If you are getting a triangle, a straight line will not be formed. So only the thing that what you can do, you see that whether the points are lying on the straight line or not. If they are lying on the straight line, they don't form the triangle. If they are not lying on the straight line, we can directly say that they form the triangle. So let us start doing this sum, children. Let A is equal to 3 comma 2, B is equal to minus 2 comma minus 3, C is equal to 2 comma 3. Now what we need to do? We have to find out the distance between AB, BC and AC. So what is AB? AB is root of x2 minus x1 whole square plus y2 minus y1 whole square. So let us take A here, B here, 3 comma 2, minus 2 comma minus 3, x1, y1, x2, y2. So root of x2 minus 2 minus x1 3 whole square plus y2 minus 3 minus y1 2 whole square, that is root of minus 2 minus 3 minus 5 whole square plus minus 2 minus 3 minus 3 minus 2 again minus 5 whole square, that is root of 25 plus 25, that is equal to root of 50. 50 means 2 25s are 5 5s are. So root 50 you can write it as 2 into 5 into 5. So instead of 2 5s I will take 5 out. 5 root 2 is AB measure. Now let me go to the AC. How will I get AC? Now BC first we will do. BC is equal to root of x2 minus x1 whole square plus y2 minus y1 whole square. So let us take B and C. What are the coordinates of B? Minus 2 comma minus 3, and the coordinates of C 2 comma 3. So x1 y1 x2 y2. So that is root of x2 2 minus x1 minus 2 whole square plus y2 3 minus y1 minus 3 whole square. So this is equal to root of 2 plus 2 whole square plus 3 plus 3 whole square. Root of 4 square plus 6 square. Root of 16 plus 36. Root of 42. So 42, 2 2s are, 2 1s are, and 3 7s are. So all are prime numbers, so we can stop it here itself. BC is root 42. Now go for AC. AC is root of x2 minus x1 whole square plus y2 minus y1 whole square. So A and C, A coordinates 3 comma 2, C coordinates 2 comma 3. If you take like this, children, x1 y1 x2 y2, this will help you to do the problem perfectly well. Otherwise you may find it difficult while taking the values. So x2 is 2 minus x1 is 3 whole square plus y2 is 3 minus y1 is 2 whole square. So this is 2 minus 3 minus 1 whole square plus 3 minus 2 1 whole square. So let us do further. AC is equal to root of minus 1 whole square is 1 plus 1 whole square is 1. So how much you are getting? Root 2. Even for root 2, you cannot have any simplification. So let us see AB plus BC. What is AB plus BC? What is AB? 5 root 2 plus BC, I have got root 42. So in any way you cannot add. Then AC, you have got root 2. So we will be saying that AB plus BC is not equal to AC. Therefore, the points are not collinear. Are not collinear. That means what? They do not form straight line. Therefore, ABC form a triangle. So we can say that triangle is formed with these sides. This is the example 5, children. Please note it down. So I hope I am clear, children. When the given 3 points are collinear, they will not form triangle. When they are not collinear, they will form triangle. So collinear or not, I have seen use the formula AB plus BC. If you have any doubt like this, you can draw a line segment, children. A, B, C. You can write like this. So AB plus BC should be equal to AC. That is what we have done. We have found out that they are not equal. Since they are not equal, we will be saying that they form triangle. They don't form a straight line. Okay, children? Please understand this and write it down. With this, I am going to conclude my topic today. In the next class, I will be doing the next part.